dear class 6 students. So we'll continue with the same chapter, magnetism, which I have started in the last class. And also I have explained you about in this chapter I have explained you about the term magnet, the natural magnet and the artificial magnet, and magnetic and non-magnetic substances. Now today we will discuss three things here. Number one is the poles of a magnet, second one is the properties of magnet, and third one is the magnetic field. So three things we will discuss it today. Number one is the poles of a magnet. Now poles. Now always a magnet, either it can be a natural magnet or the artificial magnet. Magnet always has got poles. Okay, and these poles are present near the edge of a magnet, near the end of the magnet. So there are the two poles, north pole and south pole. Two poles are there, north and a south pole. And this pole, in this region, on these poles, the attractive property of a magnet becomes maximum, rather than at the center, of this magnet. Okay, center of the magnet, the attractive property of the magnet is maximum at the poles. So when we define poles of a magnet, it is a region on the magnet where the attractive property is maximum. It is the region on the magnet where the attractive property is maximum is known as the poles of a magnet. So that means when you bring a magnet near the magnetic substances, these magnetic substances get attracted maximum at the poles rather than at the center. That means the attractive property is very much powerful, or it is very much concentrated at the poles here. So there are the two poles, north pole and the south pole. So always the magnet has got two poles, north pole and south pole, and these two poles exist near the edge of the magnet. Then the next point is there. When you suspend a magnet, let us consider a bar magnet. Bar magnet is somewhat in the shape of a rectangle, and this bar magnet is a artificial magnet, because artificial magnet are you'll find artificial magnet in the various shape. Last time I told you, okay, about the artificial magnet, horseshoe magnet, U-shaped magnet. You'll find cylindrical magnet. You'll find a bar magnet, and also the magnetic needle. All these are artificial magnet. So when you take a bar magnet and tie the bar magnet with a silk thread, a thread is there, and that thread should be a silk thread. When you tie that bar magnet and suspend it freely and just hold it on your hand, this magnet, they moves for some time, and after some time what will happen? They always comes in the state of rest, and when they comes in the state of rest, they always point to direction, north and south direction. So that means this magnet is also very useful to locate the direction. So therefore a freely suspended magnet always point out towards the geographical north and geographical south. Okay, so this is about the poles of a magnet. So remember that there are the two poles in the magnet, north pole and the south pole, and these poles in the poles of the magnet, the attractive property is maximum. Next one is the properties of magnet. Now properties of the magnet means, number one property is a freely suspended magnet always points towards north and south direction. A freely suspended magnet always points towards north and south direction. Number one property. Second property is there, like poles of a magnet repel each other, and unlike poles of the magnet attract each other. Which means that, suppose if I take a two magnet here, okay, suppose if I take a two magnet, one magnet facing a north pole, that means two poles are there, north and south, here also north and south. So that means when you bring the two magnet, opposite poles of the magnet, that means first magnet is having a south pole, another magnet is having north pole. So that means these are the two opposite poles. When you bring the two opposite poles of the magnet towards each other, they will attract. That means attraction will be there. So opposite poles of the magnet will attract each other. And when you bring the like poles means the same poles. One magnet having north pole, another magnet also having north pole. When you bring closer to each other, then what will happen? Instead of attraction, repulsion will take place. That means there will be no attraction. We call it as repulsion. So therefore, like poles of the magnet will repel each other, and unlike poles of the magnet will attract each other. This is the second property. Third one is there, the magnet always exists in a pole. Okay, the poles of the magnet, when you try to separate the poles of a magnet, even if you break the magnet or you keep on break the magnet into small and small parts, that magnet always has got a pole. You cannot separate the pole. So therefore, you can say that magnet always exists in a poles. That means if I take a very long magnet here, okay, having a north and a south pole. Now I go on breaking it. Okay, a long magnet is there. I go on breaking, and finally I get a very small piece of magnet after breaking up. And that small piece of the magnet also has got poles on them. That means the broken part, if you break one pole of the magnet, that broken part will exist another pole there. If you try to separate the poles, you cannot separate it. Okay, that means if you want to separate or if you want to break it, though you break the magnet into smaller and smaller and smaller parts, but that smaller part of the magnet still has got poles on them. Okay, you cannot separate the poles. The broken part, if you break the north pole of the magnet, the broken part again, the another part will again behave as a north pole there. So therefore, you cannot separate it. You can say that, and the next property is there, magnet always exists in a pole. So this is about the properties of magnet. Now the next one is the magnetic field. Okay, so in a magnetic field, suppose if I draw the magnet here, okay, suppose there is a magnet. If I keep a magnet on the table or wherever, okay. Now the space just around the magnet, okay, there is a force acting around the magnet, and that force we call it as a magnetic force. That we call it as a magnetic force. That means suppose a magnet is there, okay. Suppose if I bring an iron part, there is an iron here. Okay, iron is there. And that means you take a magnet and you keep an iron at a long distance here, at further distance you keep it. The iron does not get attracted. But when you bring that iron closer and closer and closer to the magnet, what will happen? That iron automatically comes and attracts with the magnet, because iron is a magnetic substance. So iron automatically attracts with the magnet. So why that iron is attracting with the magnet? Because around the space of the magnet, there is some force acting on it. There are some force, and that force we call it as a magnetic force. So the magnetic force will exist around the poles of around the magnet. Okay, and this force which exists around the magnet, this force will make the magnetic substances to attract towards the magnet. Okay, and therefore this space around the magnet, the space around the magnet where the magnetic force is produced, is known as the magnetic field. Is it clear? So therefore the magnetic field means around the space of the magnet, around the space of the magnet where the magnetic force exists there, so that we call it as a magnetic field. So the magnetic field is produced in the magnet, and this magnetic field is produced within the magnet, within the space of the magnet where we have kept. Okay. The next one is the magnetic lines of field. First one we have discussed the magnetic field. Now magnetic lines of field. So magnetic lines of field means these are the magnetic lines. Look at it. There is a curved line. Now you take a magnet, you take a piece of paper. Okay, and you just spread the iron fillings. Iron fillings means the dust. Okay, a small the dust of iron. You just spread the iron fillings on the white sheet of paper, and on the top of the iron fillings you keep the magnet. Okay, so when you keep the magnet, these iron fillings will form as a definite patterns of lines. That means they will arrange themselves, and when they arrange themselves, they forms like a curve like this. Okay, and this curve, these lines which we have seen here, these are the magnetic lines of force. And these magnetic lines of force exist because of the magnetic field. Okay, because as long as this curve will exist there, up to that point, the magnetic field is produced there. Okay, and beyond that, if there is no curve there will be no magnetic field. And therefore when we see this, and we have seen the curve here, and when you come to the characteristics of the magnetic lines of force, number one characteristic is it is a close and continuous curve. It is a curve. They are very close and continuous. This curve are continuous, and this curve passes from curve passes from north to south pole. Okay, inside the magnet. This is inside the magnet. Okay, inside the magnet, this curve passes from north pole. You can see the arrow sign here, north to south pole, and outside the magnet from south pole to north pole. That means this curve will arise from the north to the south pole outside the magnet, and inside the magnet means towards the poles here. Inside the magnet, they exist from the south pole to the north pole. Okay, so this is about the magnetic field and the magnetic lines of force. So therefore, when we discuss about the poles of the magnet, properties of the magnet, okay, magnetic field, and also along with the magnetic field, magnetic lines of force are there. So all these things are present in a magnet. Thank you.